getting close to time to get started again. And we're going to dive into how you actually, Tom is going to explain UPS and CVMFS shortly to us. And then we're going to dive into how to do LAR.
Yeah, we're really short on time. So let me share my screen. Let me share my whole screen here. Okay, everyone see my screen? I guess I should go look at the Dune one. Okay, maybe only very briefly on CVMFS. Kirby already covered this, so I'm not going to talk about it very much other than the fact that there are central publishing servers, some at Fermilab, some at CERN, and local caches at grid and worker sites, interactive sites. And that's the local cache that you interact with. And so it's a lot more efficient than to distribute a file from a central server to thousands of batch workers one at a time. It's much more efficient to have a local cache where the local cache distributes to the worker nodes. I should show you a feature about CVMFS, and that is if you just LS it, actually this LS has lots of CVMFS. Um, let's SA it to a DUNE GPVM. And let's use Kirby's favorite one because that seems to work better. Maybe it doesn't work as well for me. And see what's in CVMFS is that you won't find everything that's mounted in CVMFS when you just LS it, but it auto mounts. So if I LS CVMFS Nova, the open science grid.org, it will mount it. And now I can LS CVMFS, and now it's should be there. So it wasn't there before. So if you just look for things in CVMFS and don't find them, keep LSing and it will auto mount. So that's the only interesting feature about CVMFS I should mention here. It's something like AFS, except it's read-only, and that's because of the publishing caching model. That's all I'm going to say about CVMFS. Let's go to UPS. UPS is at least 30 years old now, and it's meant to solve a lot of the problems that we were discussing earlier in the day about setting up an environment and making sure that your environment is consistent. So the idea behind UPS is that pre-installed software is available in locations like CVMFS, and there were uh, mounted disks like Grid Fermia before CVMFS, and CVMFS is a better solution. But the idea is that UPS lets you pick versions of things in consistent stacks. So if you've got a whole bunch of products that you need to set up, and only some versions of products work with some versions of other products, it becomes very hard to keep track of it all. And some of the discussion that we had early in this morning when you had to set up a particular version of Python to get Metacat to work, then it sure would be nice to automate that instead of having instructions and getting it wrong sometimes. So that's what UPS does, is that if you set up a top level product like Dune software, you will get everything set up underneath it. And I should show what the dependency tree looks like. So here's what the Dune software dependency tree looks like for version 10.04. That's actually today's version. And if I zoom in on the Dune software part, there's 10.04 D00. And there are all these other products. And you might recognize some, they're familiar. The root is in there, Géant is in there, Xroot D is in there, Art and LArSoft, and a whole bunch of things that you may be familiar with, and maybe some things that you're not, are in the stack, and they get set up automatically when you set up the top level product because the other because they're needed by the top level product. Other things that UPS does and that SPAC will do for us is that when you set up a product, you get environment variables, and LArSoft jobs need several search paths. So you may be familiar with the path variable, which will show where to find commands. And my very simple login has very little path, and that's just the system path. But say if I set up now, later on in the tutorial, I'll talk about the container. I've got an alias for that container command, so I don't have to cut and paste a long container command or even remember it. But the problem with the container command is it doesn't source your profile. So you don't get any login environment variables. In fact, your prompt won't be set. It'll just say apptainer. So I prefer a prompt that says what machine I'm on, or maybe even the directory I'm in. The one that I have on my own desktop here at the lab actually sets the prompt to tell me that I'm actually in the SL7 container. And if you have some sessions that are in SL7 and some that are in AL9, it sure is nice if you set the prompt so that it says SL7. So some of these environment variables that are needed, so path is one of them. And I've got an alias to set up all these things. Path. And this is a very long list of places. It's colon separated search path looking for places to find executables. And the which command goes and looks through the path and finds the first one that has a particular command like lar, or you can even do which ls to show where the ls command is. So it'll look through the path and find that. There are other paths for looking for shared libraries, fickle files, and other things like GDML files and other associated data files. So these things are set up by UPS and already, even if you like to run root, I'll tell you which root that you're running. In fact, there are lots of versions of root installed, and the one that's in your path is the one that you'll get when you fire up root. If you want to know what you set up, how about UPS active? We'll tell you what you've already set up, and my font is way too big so that you can see it. Oh, yeah. So this is that stack that I showed you of products. Let me make sure I can grab the screen later. And DUNE is in the list, and all the things that it's set up and the versions and where to find them are listed in UPS Active. List AK plus could be default. We'll show you all the versions of DUNE that are available and set upable. Okay, that's all I really want to say about UPS. It's going away. It's being replaced by SPAC. There isn't that much to UPS. It's just a bunch of setup scripts. But the issue is that the dependent products, all these things in that list that I showed you when you set up DUNE software, things like external packages, even things like Valgrind and Triton and libtorch and um, TensorFlow are very hard to build and maintain. So what what we want to do in the future is use SPAC recipes that are provided by the authors of these packages instead of Fermilab staff rebuilding these things under UPS. So that's the reason to move to SPAC. But for now, we're going to use UPS. Let's go on to LArSoft because not a whole lot of time. I'd like to make an advertisement for Dom and Kirby's workshop at CERN. It's in February, I believe, and I've got it.
Right after the collaboration meeting.
Yeah, it's after the collaboration meeting. So it's at CERN, and this page is password protected, but it's 3 days long. My little chat here is about 40 minutes long, if that. So you will learn a lot more about LArSoft at this workshop than you will in this training. But so I would like to, of course, advertise that. The thing about LArSoft is that it's framework code, and framework code is not there to make your life easier in the short term. It's there to make your life easier in the long term. So the idea is that we have a lot of people on Dune and LB&E before that who wrote a lot of code. And we want to make sure that they don't step on each other's toes when you run a program that includes bits of code from different collaborators. So that's the whole point behind the framework. And I should mention that perhaps one of the most important things that it does is it collects inputs and outputs. So if you've got many people and they're producing different quantities that they calculate from the input data, and you put the output data somewhere, you don't want to have one output data file per bit of code that you ran in your framework job. So if you have 100 little things that you're doing to the data, you don't want each job that you run producing 100 little data files on the output. You want it all collected together. And one of the reasons why this is so important is that it's very hard to take a bunch of files that are scattered with little bits of data that you have to associate with other little bits of data in other files. That means you need all the files, but you have to open them and you have to dig through them and find the right bits of data in them. So Art uses root T trees and puts data products in entries in T trees so that you can associate them very easily and loop over. Art calls them events. We call them trigger records on Dune. So those are the most important features of what Art is doing for us, and it makes data files with data products in them. And usually an Art job has another output file that has histograms and your own user-defined trees. So you get one Art root file with an Art root T tree, and then a user-defined histogram file that is using the T file service. So on the setup side, I've got these aliases that I mentioned before. If I want to set up a container, I just run this command called DUNE SL7. And I think I even typed that over here to set things up. So it was called DUNE SL7, alias SL7, and I have that alias in my profile. The build node, and there's not enough time to describe today how to build code, but the build node does not have dcache PNFS mounted. So if you run this alias, the fact that it mentions PNFS slash Dune will fail, and then you'll get an error message. So I have a separate alias that I run on the build node. And then this Dune setups is just the UPS setup script that Steve mentioned earlier. And I just have an alias called setups because I wrote my alias long before the tutorial. And that just runs the setup Dune script. And this is how you set the prompt. So if you don't like the apptainer prompt, you can set the prompt to anything you like. Okay, so the setup with a particular version is also something that I have an alias for. But what I recommend here is that you can cut and paste this to a setup script that I believe is in the mission setup tutorial that sets DUNE version to this and the qualifier and then sets up DUNE SW. I have an alias for that, and it was called root 6. And the alias is just to do the setup script and then just set up the DUNE software with the version. And that's all you need because once you do that, you actually have the environment variable DUNE S underscore version. One reason to have another variable like this, DUNE version, is if you need to set up a bunch of pre-installed products, but then you need to build one of the products and replace it with the other one, it's nice to have something that isn't part of the setup so that you can override it with your own. So Steve already mentioned how to access data files. I grabbed one recently, and it's in my area. Maybe I should just show you what's in it. I already showed you how to query UPS. So let's look at some Art command line tools. So cd exp data users here. By the way, you should put data on the data disk and not the app disk because the app disk is smaller. And I did the testing of all this tutorial in November, so I just called it November 2024, and then I copied an extra file today. So, in fact, let me skip ahead and show you where all these files came from. So, workflow, I'm just going to that. Why is this not searching? Example workflow. I did this as part of the preparation for this tutorial. I ran through all these commands, and you can do this yourself once you set up the container and run in this. And then you get these files, one for each stage of processing. So a typical workflow has a generator job, a Geant stage one, and a Geant stage two job. I think the Geant stage one does all the particle tracking, and Geant stage two does things like the photon detector things. The DETSIM, on the other hand, calls WireCell, and that simulates the response of the TPC wires. And it's got stage one and stage two. I think stage one does most of the WireCell, and maybe stage two again is photon detectors. And then there's a RICO. Let's see, there's only one RICO stage one that I have here. And then let's, so actually, let's see, event dump. Event dump is a fickle file. I have some tools that I may list in here. XP, DUNE, data, users, tier J, X tools. So I may list this. I've got a few very short scripts that I have that go and look up, say, fickle files. So if I ls fickles, yeah, star dump star dot fickle is an alias I have to one of these commands that looks up, or rather does searches through a search path and lists all the things in the search path that match this wildcard. So I want all the fickle files in fickle file path that have the word dump in them. And then event dump is one of them, but I can dump all sorts of things. And this is part of the fun of LArSoft, is that you get all these data products for things like hits and clusters and op hits and raw digits and things that might be in your output file. An event dump goes and dumps, or at least lists them all. So I ran event dump, and let's see, then I made event dump output. Actually, I'm on a VNC, so I can do this. Use your favorite text editor. I have an alias to Emacs with my favorite options. And those options are mainly to turn it green. And event dump will list all the goodies that are in this. It's a Monte Carlo simulated Jan4, DETSIM, and RICO went in there. So MC truth is the output of the generator. MC particles are the output of Geant. Some MC particles are actually owned by MC truth. So you'll find that, like, if you run Genie or the particle gun, you'll get an MC truth for the particle that the particle gun made, or all the particles that Genie made. Uh, and you'll also have MC particles for them. But then other MC particles are made by Geant. So this is the module name, is LARGeant makes MC particles from all the interactions with the detector. So you may actually have to go look for two sets of MC particles to get all the MC particles that you want. And then the simulated things, my favorite, of course, is raw digits. Sim channel is a truth information for what happens on each channel. We have things like triggers. PF particles are made by Pandora. There's a separate talk that I linked in the tutorial by Tingjun at one of the uh, uh, workshops back in 2019 describing the data products. So raw, reconstructed, and analysis and simulation information have different data products. And this is, say, the output event dump.fickle that on an input file that I mentioned. My favorite is raw digit. In fact, I should show you how to display these. So let's go back. Root 6 just sets, essentially just does that setup script that I already showed you. It sets up DUNE software. And I've got CD MP04. I've got a file that I already decoded. To go this very quickly. So actually, maybe I should describe how to change a fickle file first and how to run. So the event dump command that we executed before was in the um, uh, tutorial listing. I didn't actually run it. Let's run it. Event dump fickle, and then let's pick the, oh, I don't know, maybe DetSim stage 2. I read it on the Rico, but DetSim stage 2 is perfectly fine. It's got data products. It won't have them all because it's just the output of the DetSim stage. So the LAR command here, LAR is just the top level framework um, uh, program, and it's very short. All it does is it reads the fickle file, and then it loads up all the code it needs to start executing it. So if you say which lar, which lar, you'll notice that it is only 82 kilobytes long. So the entire executable, its sole job is to read the fickle file and launch other things. So event dump.fickle contains all the information to produce these event dumps. So that's how you invoke the framework, is that you type lar and then -c says for the script or for the configuration. C stands for configuration. So the fickle file, event dump.fickle, is a configuration for lar. And then the input file is DetSim stage 2. If you want several input files, what I always do is I use the help feature of LAR, help, and then it'll tell you what command line options there are. And if you want to, say, have a list of input files, or you can, this is code for, you can actually put a whole list of input files on there. If you want to change the output file name, you have -o. -s is the source for the input file. You can actually drop the -s. And -S is for a list of input files. So if you want to run over 100 input files and you don't want to write them all on the command line, you can put their names in the file and -S. So a lot of these framework commands have help in them. And product sizes dumper, oh, is one of my favorites. So it's a lot like event dump, and I can run it product sizes number on, oh, let's say, well, Jen is going to be the smallest one. Rico is going to have everything. So a lot of jobs by default copy their entire inputs to the outputs. So you'll find that Rico stage 1 will have all the data products that were made by Jen, in addition to all the things that were made by G4, DetSim, and Rico. So the Gen is the smallest one. It's got, well, these are the trees, and the one that's interesting is events. The others are other things that the framework keeps track of, like file metadata and configuration history. And that's another nice feature of the framework, is that it remembers what your configuration was. So all the fickle things in your fickle file get saved in the output file, so that someone who doesn't have your fickle file or your environment, just has your output file, can query it and figure out how it was made and be able to reproduce it. So this job was made with Argon 39, Cosmic Rays, Krypton. Generator is code in this case for, I believe, oh, it's singles gen. So I think that's just a particle gun. So I had a particle gun and Argon 39, Krypton 85, radon, uh, and beam events. Ha. So, I might have a beam particle in here. Very good. So actually, let's look at the event display since I don't have a whole lot of time here. I do mention here how to change fickle configuration. Order of plugin execution workflows. That might be in the other session that I don't have time for, but you can read about how to edit and modify a fickle file. So that's in how to modify a LArSoft module and change configuration. So rather than reading all of this documentation, which I don't have time for, I should mention that fickle files have fairly simple syntax. What they have is parameter names and values. So I have one fickle file in my directory, evdpdhd, fickle. And the idea is that it includes a protodune fickle event display fickle file, and it changes a few parameters. So the main thing that I wanted to say about changing fickle configurations is that the easy way to do it is to take an existing fickle file, include it, and just change the things that you want to change. So what I did is that for looking at protodune, in this case, it's actually, this is NPO4 HD, that's a raw one. So actually the Monte Carlo is going to be protodune SP and the data here is protodune HD. And they differ by the fact that there are 6 APAs in protodune SP and only 4 in protodune HD, and the ADCs are a bit different.
Actually, I think it's HD Protodune, just to be
HD
even more
protodune is
computing. Yes.
the run type for finding the files, but yes. Okay, so let's use the protodune SP event display fickle, which is this one. And it turns out that the data one works fine for Monte Carlo. So if I do lar-c and then that event display, and let's make an event display for the Rico. Now we already saw from the event dump that it had things like hits and clusters and tracks because the Rico was running WireCell and Pandora and well, Gauss Hit Finder is the thing that made the hits. Okay, so the first thing that you'll see is a disappointment. Nothing. Haha. Well, this is a reconstructed file in Monte Carlo, and there's no raw data in a reconstructed file in Monte Carlo. The reason for that is that the raw data are very big, and even though we simulate it, we drop the raw digits in the DetSim stage even, I think, or maybe it's the reconstruction stage. So WireCell produces and drops raw digits, so you never see them in the file unless you ask for them. And if you do ask for them, then the file gets very big. So the standard workflow will not have any raw digits in it. However, if you look at raw data, and we'll show you some data with some raw digits. So this is all reconstructed stuff. And this is the LArSoft event display for reconstructed stuff. And you'll see that if you click on any of these views here, the waveform changes. So this is a waveform view. This is the U plane. That's the first sensitive plane that's the electrons drift in. V is the middle induction plane, and the top is the collection plane. So deconvolved hits are unipolar in all three views, but if you look at raw data, you'll find bipolar signals on U and V and unipolar signals in collection. This looks like it has an electromagnetic shower on it, and that's is just one TPC. There's a geometry web page that is linked under the protodune data access to know which TPC is which. And I can, if you ask me for a link to that, I can show it to you, or maybe I should show it to you anyway. So where is my there it is. It's actually in Redmine for DUNE TPC. And then there's geometry, wiki, geometries. Some of this actually, this is the only thing that I know the link to because it actually has links to the main wiki for the SP geometry. And there's a link to the wiki, the main wiki. And just because this is the link that I remember. So here's a description of the geometry for ProtoDune SP. Is that there are 6 APAs. TPC1, the beam comes in from the left and comes in through here and it goes through TPC1. So we were looking at TPC1 on here. And I think one of those guys might be the beam particle. And they tend to come in at like a 10-degree angle. And this shower here might be the beam particle because it looks like it's in about the right place. But APA 2, or sorry, that's APA 3 just because that's the way they installed it. TPC 2 is on the other side of the cathode. So the APA is here, the beam comes in through here, cathode's in the middle. And then we've got the other drift volumes, and those are used for analysis of particles that get out of the first drift volume. I should show you how to make the 3D display, which doesn't work on my desktop. It works on the GPVMs, which is great. So if you log in the GPVMs, you can actually get a three-dimensional display of this Monte Carlo event. And of course, not everything works as well as it should because if you quit out of root here, you'll get a seg fault, but that's fine because you're done. Let me show you the raw digits. Art and LAR. Art and LAR are actually the same program. LAR was supposed to be a customized one for LArSoft and for liquid argon TPCs, and ART was a more general one for everyone who uses ART. But it turns out we didn't customize it, so they turned out to be the same. So you can use ART or LAR. For those things that are not liquid argon TPCs like NdGAR, I tend to type the word ART instead. So here's a raw event display for ProtoDune HD. So I snarfed one of those files, and one of those fickle configuration adjustments that I made essentially just sets the range for the ADC values because the ProtoDune SP ranges are different from the ProtoDune HD ones because we're using a 14-bit ADC instead of a 12-bit ADC. And you see problems already in the ProtoDune HD data. You'll notice that the collection view is very faint. This is U, that's V. V has what looks like unipolar signals. U looks like it has bipolar signals. That's because the collection plane in ProtoDune HD on the most upstream APA was disconnected. When they cooled it down, they found out that they couldn't bias the collection plane. If you look at any other TPC, it looks reasonable. So you get unipolar signals on TPC2, which is on the other side of the cathode, bipolar signals on V, bipolar signals on U.
Yeah. How many people are actually able to do this? It may be quite slow to render if you're doing it over X.
Yeah, so I'm using a VNC here, and there are instructions in the how-tos of how to set up a VNC session.
Yeah, you have to make certain you detach from your VNC session. But
Right.
if people, this is people should, one of the goals of this class is for people to be able to make an event display.
Mm-hmm. Okay. So the VNC instructions were written by Don Brailsford. I actually had to edit my SSH config on my Mac to set things up, but I think it's pretty clear from the instructions what you have to do. So let's look at my .sh config. So I've got the forwarding of ports. So my desktop computer at Fermilab is called DUNE GPU02.fnal.gov. And for that machine only, I set these options, and it's this local forward thing that enables the VNC. And then on the GPU, on the desktop at work, here's the VNC command, and I think this number 22 has to match that 22 there. That's all in the VNC how-tos, and then I just run the VNC command. Uh,
But
with
people
the
should be able to do this over X without doing all of this. In principle, it's just really slow.
Yeah.
So people should be trying to do this event display thing.
Mhm. Absolutely. Okay, so that's event display and data products. I should mention that actually I'm sending this from a GPVM to my desktop to my laptop at home. So I've got two hops and the VNC is quick enough to be able to do that pretty easily. If another way of querying what's in these files is just with plain old root. And one of the advantages of root is that you can browse a file and look at its contents and make histograms without writing any code. Now, all the data is in this events tree, and you might find some of the other trees in there rather opaque because they're storing things like the configuration information, file index parentage. But all these things in the events tree are data products that should be familiar if you're working with LArSoft for a while. So things like MC Truth that I imagine. Okay, so that's Krypton 85. So do we have any Krypton 85 in our events? I ran one event in the example before. So how many particles are there? I just click on that. Uh, wow, my gosh, there are 273 Krypton 85 particles in that particular uh, event. So this particle list, I think, may be a pointer to a bunch of MC particles. So inside of it, of MC truth are MC particles. And then they have things like, oh, let's get the PDG code. There should be electrons. 11s are electrons. Where's their start position? Let's see. Yeah, polarization. They should have um, trajectories. Maybe not an MC truth. MC particles have have trajectories. Problem with position is that it's a 3D vector. Vx might actually be a position. That looks like a position for x. So that's an x vector, not a velocity. Those are positions. So proto-DUNE positions go from 0 to 600 centimeters at 600 centimeters tall, the active volume, and it goes from minus 360 to plus 360 centimeters, and Z goes from 0 to 700 centimeters. So that's the location of these uh, uh, particles. You can even do things like this, where it's a little awkward because I can't cut and paste from this, but I can read the things. So I do events. This is standard root thing. If you have a name of a teacher, you can just use it on the command line, draw, and then I just say SimB MC truths. They are 85. That's 2 underscore singles in knowledge F part list B Z. And see if it is able to redraw that picture. It is. And then I can use Root's nice little feature of drawing one versus another. So let's do VZ versus VX versus VY. And what this will do is this will give me a three-dimensional view of where all the krypton decays are in three-dimensional coordinates, all without writing any code. And you can do that with any data product. So you can figure out where the hits are. Hits, by the way, don't have space locations. There should be space points in here that you can do similar things that show where space points are in three dimensions. But hits have channel numbers. So so here's Gauss hit. So what's in are just the channel numbers, and there are 15,000 channels in Proto-DUNE SP, And since hits are just pulses on wires and they haven't yet been associated with other hits, we don't have a 3D Rico for hits. We just have their locations and their things like amplitude and integrals. If you want to know where some of these data products are defined, the header files, where is my, are in LAR So they're in GitHub, and I've got the link to that in the tutorial, and my little sharing thing is getting in the way. LARSoft, LAR data. Well, LAR data obj is the place where header files are. If you want to know where uh, well, MC particle, oh, MC particles actually, oh, those are MC particle light. I don't know where raw digits are. They're in raw. There's raw digits. So if you want to know how these classes are defined, you can read them in LAR data obj. So hit is in Rico base. The Rico B hit is that's what the B is, and Rico B is these are base classes, but they turn out that they're just the classes that we use are the base hit classes.
Yeah,
Okay.
people are saying that they're going to need the video to follow this,
Yeah,
just because it's going so fast.
right. Well, I have no time, and this is really a 3 day at least exercise. Did I even get to gallery? Do I have a gallery thing? Oh, let's see. Oh, I didn't put the gallery script here. Okay, I might be running out of time anyway.
You are Sigh.
Okay, so what else is on my tutorial list other than showing you how to get at these data products once you run a large job? Oh, well, okay,
People should be able to do this, read the instructions and go back and follow through on their own if they feel comfortable about asking us questions, which you now know that we get a lot of them.
right. I think Steve asked me to talk about like Lars or the copyrights. And the main thing about copyrights is just don't be scared of them. So if you look at the copyright notice for Dune SW, for instance, that's in github.com/Dune, Dune, Dune SW. That's the typical copyright notice. And what we use is the Apache v2 license. It's an open source license. Anyone can read and copy and use our code for any reason whatsoever. And we like that. If you look at the prime contract for Fermilab, it says that the software we develop is copyright Fermilab, but it's open source. And that makes sure that we can use our own software. So if we put our software up on the web somewhere, some third party isn't going to go out and say, oh, I own the copyright to your software. You have to pay me. So that's the only reason why we have this copyright is to guarantee that we have access to our own software. However, contributors from other institutions who don't work for Fermilab don't have to play by Fermilab's rules. They can play by their institution rules. So if you put some code in a Dune repository and your institution says that it owns the copyright and not us, then you can put a copyright notice in there. Just make sure that it's open source. And we're pretty sure that most institutions have open source rules for software. I've noticed that some people are very jealously guarding their firmware, however, for the DAC. That's actually not the case for the WIB firmware. I know where to find that. That's open source, but some firmware is pretty closed. So it's harder to get a hold of firmware, but all of our software is open source. Okay. Anything else? I think it's noon. I'm out of time. Did you want me to keep talking?
People could vote on that. If people, maybe I think the best thing might be just to say that we're done, but people can hang around and ask us questions.
Yeah, I
That might be the right thing to do.
love questions. It didn't even talk about building things. That's
Yeah,
another.
no, no, that's cut out of this one. We may just need to make this into a separate tutorial and do it again, starting with what you're doing here.
Yeah. Well, we
Okay,
have
so
videos.
folks,
We have
ask
videos of the old one.
questions.
Yeah, we have videos of the old one. I was actually going to think about say showing people how to make a pull request. But if you just Google that, you just say how to make a pull request GitHub, and you'll get some really nice instructions. That's how I learned how to do it.
But I'm busy typing up responses to the most common questions.
Let's look at the live doc.
So I think the main thing is that even if we got behind on this, people should be able to work through the examples on their own time because we got a little rushed here and things went wrong. So if go back, go through things. This is also on the web as a reference so that if you sit around and you go, gee, I forgot what Kirby told me about the 7 different kinds of disk. We have the picture and we have the taxonomy of different kinds of disks. We have the Slack channels, and I think the main thing is that what we're discovering and we're finding we're in the middle of a lot of transitions in the software and code that we use, and those can come back and bite you reasonably quickly. The thing to remember is it's not you being dumb; it's the computing system having changed drastically since last Wednesday, and which is it's the fate of anybody doing high energy physics computing. The underlying landscape moves very quickly, and we're dealing with huge amounts of data and very complex code stacks. So your job is to find problems and report them, and our job is to, well, help you fix them.
Right. So the setup has to be ironed out. So even though there's a lot of complexity underneath, the interface needs to be simple. And
Yeah.
it used to be simple, but now that some of the bits have changed underneath us, we have to scramble to make it simple again.
Yeah, so one of the things we're going to do for the next version is I'm actually going to point out in the introduction those example setups because people who had just done the setup probably had most of that setup already because that was part of the instructions for the setup. But if you hadn't done it recently or didn't do it, you'd be completely lost. So we're going to make it so that we're just going to point people to the example setups, which you can store, but you're going to have to update them because things are going to change. So anyways, I would like to thank the people who provided answers. And I think we're going to go over to the live doc and people can just, I guess I can share my screen and we'll go to the live doc. And if people still have questions, I will stay here and try to answer them. But otherwise, class is excused. Party time.
Sunny has her hand up.
Oh, okay. Let me. Yeah, Sunny, what's up?
I have 2 simple questions to Tom. So Tom's case, he gave, examples of this, looking at the files, but those files are in, your directory or, our own directory. But in principle, we have to access the files, which is in, certain area, maybe including PNFS. So the first thing, firstly, we have to identify using, metacat where we want, where is the file. So to look at, those files using either lar command or root, we have to give all these, paths to the file, right? So it's not so simple that you give your file name, which is under your directory. So
Yep. So I set it up to make the tutorial quick. However, of course, if you want to access the file directly, say in Dcache via xrootd, you put the xrootd URI, the one that says root : / and the long path. You just put that on the input line where you put the file name here, and LAR will know what to do.
Yeah, but for that, we don't need IFDH, right?
Nope.
IFDH is only for the copy move, MKDR.
You don't actually need the IFDH. You need to, because you've already got that command. You have the location. The xroot command will lar minus C something, your fickle file, and then the the path that starts with root colon will in fact read that file. And you can do the same with root. That's why in I think in the example we actually had I guess it was in the data management, which we probably ran out of time for. We actually had examples of opening files in root using that kind of information, I believe.
Mm-hmm. Another question is, if I want to know, what pickle files are used for each stage of the simulation, let's say from the generation to the reconstruction. For each stage, there is a single pickle file. To know that, is it Metacat is the right tool to know the list of those?
Metacat should have that pickle file in it.
For each stage, not the entire list of the pickle files.
No, you probably have to go through the parentage to get the full list.
Parentage?
Yeah, I thought the catalog has the parent files, but not maybe I should read the metadata, but the name of the fickle file. I always have to talk to the conveners because each detector, like NPO4, NPO2, iceberg, far detector, vertical drift, horizontal drift, has its own simulation and reconstruction chain. And they usually have a wiki with a list of these. And I'm listing for the DUNE
there's a production, the production request page is a good place to look. But in principle, what you can do is each file has parentage, and there is also a Python API. We could write a script that could get you this, but what you have to do is you look in the metadata, and the metadata will tell you the name of the parent file, and then you look in the metadata for that one, and you see what fickle file was used to make it, and then you look in the metadata for that one, and you look for things that are done all in one production chain. I believe that we sometimes list all of the fickle files in the job. And for Monte Carlo, we definitely have the generation stage one. But to get the full sequence, one probably needs to write a script that actually just goes up the chain and pulls out that fickle information. And that would be pretty simple to write. If Ethan is still here, I may give him that one as a homework assignment. That will toughen him up. He's new. He's been here for a week.
Okay.
It's easy. Let's see.
Actually, on Sunny's point about reading files directly out of Dcache, works great for commands like root and lar, which is using root underneath. But HDF5, for instance, doesn't understand xrootd yet, but there is a way to do that, but you have to read the how-tos in the wiki for how to do that. There's an environment variable that you set.
So there's well, once again, why aren't we setting that environmental variable as a matter of course? And why don't we make a wrapper for LAR that actually prepends that environmental variable so that the command people type in does what we want it to? Just saying.
The second one might be more useful because it actually breaks some commands, so you don't want it everywhere.
So that's the thing. I suggest that we actually possibly even alias LAR so it prepends that command.
Or have our own non-LAR alias, DUNE-LAR.
Yeah, that would be good. So, Tom, your job.
Or maybe it would be xrootd-lar or something.
Yeah, there's some other things we should be putting into probably the standard setup, like the location of Metacat. Hey, why isn't that part of our standard setup? There's a lot of the stuff that we're asking users to do as part of the setup right now that probably should just be if you set up, something, that's it. I mean, that we do it for them rather than having them have to figure out which version of IFDH and all that stuff to set up.
Well, when you set up DUNE software, you get IFDH set up for you with UPS. And
Okay,
that's a
but
that's a plan to do it in SPAC as well, but I can't prove that that works. Especially since Steve's location of Metacat is in a different SPAC repository than the latest LArSoft.
oh God.
So we have to
Okay. Well, anyways, we need to start moving some stuff into the standard setup, which means more maintenance on the standard setup because we can't have every single user like. But for example, the location of the Metacat uh, site that should just be hardwired into the DUNE setup. Okay. Let's see if there are any other questions.
Well, the UPS one is hardwired. So the main setup script is all UPS based. And I don't think we have a default spec setup yet because there are two places where the LArSoft people have put things, and one's older than the other.
Yeah, we don't have a default LARSoft setup, but for example, if you do the Metacat locations are actually set by default in the spec setup for Metacat, or at least are set up in the DUNE setup for Metacat. So there is that. So let's see. I'm trying to see if there are more questions. Let's see the chat. Okay, so anyways, people should ask us questions. Keep asking questions. And I'm writing a frequently asked questions based on this that will be added to the extras in the tutorial. Does anybody else have questions? And thanks, Sunny, for asking these questions. We'll figure it out.
Thanks.
One thing I think we need to do is probably limit attendance and do these things more often because with 60 people, it's really hard to answer everybody's questions.
It sounds like ironing out setup issues is what took a lot of time today.
Yeah, well, part of it is because we have to do both SPAC and the Apptainer. And it's also true that we used to just sort of assume that people had gone through the setup procedure. And so they already had that setup script, the aliases and stuff that you had suggested. And so now what I'm going to do is I'm just going to, in the introduction, I'm going to point them to those two canned setups, and we'll spend a little time redirecting them, and then and making any edits that need to be done.
Yeah. And people
By the way,
bits of extras from their other experiments or whatnot. Tends to be
yeah, that's a real problem. But if we all running the same setup script, then in principle, we can at least catch the extras. The setup.html actually warns about that multiple times. But I have a feeling a lot of people were running into the fact that they put a lot of stuff in their dot profile, and just basically you just shouldn't do that.
Right.
I don't have anything in my dot profile.
Same here.
Yeah, and I mean aliases and stuff are fine. For example, if you want to have all the setups, just you type one thing to run multiple setups. But yeah, as Heidi says, definitely don't have things that just automatically run as soon as you log in.